Hello guys, I'm back. In this video, I will talk to you about having a pressure safety device in the discharge of a centrifugal pump. My name is Jeferson Costa and I teach students, graduates and engineers how to work with chemical process engineering and plant design. Follow my profile and like this video to have hundreds of videos and contents related to chemical process engineering and plant design. Once we finish the process simulation and the heat and material balance of our process and we develop the process flow diagram of the process, it's time to start with the piping and instrumentation diagram. The piping and instrumentation diagram will have information not only related to the main equipments that are used in the process, but also about the safety fittings or the safety devices that are needed to protection of the process. And one of the cases where we use pressure safety device or pressure relief devices is in the discharge of reciprocating compressors and reciprocating pumps or positive displacement pumps. And why we do that? Every time that you have a positive displacement pump or compressor, we need to add a pressure relief device in a case of discharge block of this equipment, because as they use a constant volume to add pressure to the system, if we block the discharge, the pressure will go up, will increase, will keep increasing until it ruptures the system. So to prevent that, we use a pressure relief device. Let's talk about a PSV and what will be the required flow for this PSV. The required flow will be the full flow of the equipment. If I am transporting 100 cubic meters of fluid in the pump or in the compressor, my flow rate in the discharge, my flow rate in the pressure relief device will be 100 cubic meters. But now let's think about centrifugal pumps or centrifugal compressors. The way they build pressure in the fluid is different. They use the acceleration of the fluid, so we have a curve of performance. And when we increase the resistance of the system, we increase the discharge pressure, but we decrease the flow. And a point to evaluate in this kind of equipment, centrifugal equipment, is the shut-off condition. It's the condition when we start the machine and block the discharge, and we verify what is the maximum head that the equipment are able to achieve. If the maximum head that the equipment is able to achieve plus the maximum inlet pressure is below the weakest part of your system, most often the nozzle of the pipings. If your maximum discharge pressure is below the design pressure of the piping system, you don't need to add a pressure relief device. And if you have any equipment in discharge of the centrifugal pump that has a maximum allowable working pressure above the maximum head of the pump, considering maximum head and the maximum discharge, that is head plus the inlet pressure. If the maximum allowable working pressure is above this discharge pressure, you don't need to have a pressure relief device in the equipment to protect this equipment, because you will not because of this, because you will not be able to build pressure above what is considered in the centrifugal pump or centrifugal compressor curve. And in this case, we are evaluating discharge block. So, but there are some cases where the project, or if we need to use an existing pump, or if our system are being upgraded or debottlenecking, there may be situations where the maximum discharge of the centrifugal compressor or centrifugal pump will be above of your design pressure or above your maximum allowable working pressure. If that happens, and you will evaluate that based on the equipment curve, you will need to add a pressure relief device for the discharge block case. And what will be the flow rate required in this case? As we have seen in the positive displacement compressors, we have a constant volume going to the equipment, and because of that, we need to consider the design flow as the design flow required for the pressure relief device. But for centrifugal compressors or centrifugal pumps, it's not the same criteria. We need to evaluate in the pump or compressor curve what will be the new flow when we increase the resistance or when we have the PSV set point reached. We need to evaluate in the curve of the equipment what is the new flow. So in this case, it is expected that the required flow for the PSV will be lower or eventually much lower than the required flow for operation of the machine. And in this way, you will protect your system and you will have a smaller PSV instead if you consider that the required flow for the PSV is the same as the normal operating conditions. What are other reasons to having pressure relief devices in your piping and instrumentation diagram? If you want to know more about it, take a look in this video that will appear to you right now. Share this video to help others, students, graduates, and engineers to know more about chemical process engineering and plant design. This is it. I hope you like it, and I'll see you soon in the next video. Bye bye.